Hello students, welcome back to today's class on basic geometrical ideas. In that we are in the lecture number 3. In the previous classes we discussed what is a line, what is a line segment, what is a ray. Also we have discussed what is a curve, right? A straight line as well as a curved line, and we have discussed a couple of applications based on that, right? So let's try to discuss more applications or more concepts with all these, and also we're going to discuss about angles and then also with circles, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is the first thing that we're going to discuss here is angle, which we have already covered in the last class, but once again for a quick recap, let's try to discuss what is an angle. And for angle, we need to have two rays starting from the same point, which is a vertex, okay? So we have a vertex and we have two rays, both the rays are called arms, right? And the measurement that we can obtain here, let's say x, so that is an angle. We have separate systems for that. We say 30 degrees, 40 degrees, 50 degrees. So we are going to discuss that in the coming classes, right? So that measurement is x. Angle is formed using vertex and two arms. You can see here. An angle is formed when two rays originate from the same point. Originate means they start from the same point, right? The rays making an angle are called arms, and the common point is called the vertex of the angle. So here, this point is the vertex, right? So from the vertex only, both the rays starts their journey, or both the arms start their journey. So yesterday we have discussed about this one, right? And also we have discussed the angle is a figure that is represented as, right? So here ABC. So this angle we write as angle ABC, or which is also equal to angle CBA. Angle CBA. So angle is represented in this shape, okay? Angle A, angle B, angle C, in that way, right? So now let's try to discuss what is an interior of the angle and what is an exterior of the angle, which we haven't discussed yesterday. The points between the two arms, and the exterior is points outside the two arms. So what do you mean by inside and outside of two arms? So let's try to take an example. Points between the two arms. So these are two arms, correct? So all the points between these two arms, all these points are inside, or we say interior, okay? So all these are interior. So this angle, whatever you are trying to measure, okay, so that is the interior. Let's say x, okay? So that is an interior angle. Angle x is an interior angle. The same way, when we're discussing all the exterior points of the two arms, all the exterior, that means all these points, right, which are not inside. So this angle, whichever we are trying to find, which is y, right? So here y is the interior of the angle. All the points here are the points inside or the interior of the angle, and all the points outside which are in the range of y are exterior of the angle, right? All the points which are in the range of y are in the exterior of the angle, right? So in the figure, what is a vertex? I said you, vertex is the point from where both the arms start their journey, or both the rays start their journey. So here vertex is B. Now what are the arms? Arms are nothing but the rays. So one ray is BA, or you can say AB, right? One arm is BA and the other is BC. These two are rays. You can just write this symbol to represent that they are rays, or you can simply say AB and AC, okay? AB and BC, okay? In the same way, angle, what is the angle here? So angle is represented as ABC or CBA. Wherever the angle is formed, that should be in between, right? So ABC angle, ABC or angle CBA, angle ABC or angle CBA, correct? Okay, so this is how we can try to represent angles. So let's moving forward. Name the angles formed in the given figure. So we have a figure here. We need to write all the angles that are being formed. And you can observe how many angles that can be formed. There are 4 angles, right? So this is one, this is second angle, this is the third angle, and this is the fourth angle. So total 4 angles are formed. So how can we write like that? So the first angle A, for angle A if you want to represent, so we need to represent it as angle DAB. You can write angle A, right? Even this is correct, but more significantly, we write that is starting from D and then meeting A and then meeting B. So DAB, this is the angle which you are talking about. Right? In the same way at angle B which we represent ABC. Angle ABC, right? In the same way angle C, BCD, angle BCD, and the same way at the angle D, we can say CDA, angle CDA. So total how many angles that are formed here? So there are 4 angles that are being formed in this shape. The 4-sided polygon, as I told you, it is a quadrilateral. It is a quadrilateral, right? Again, in quadrilateral, we have different types of quadrilateral. One is square, one is rectangle, one is rhombus, trapezium, parallelogram. Don't worry, we are going to discuss all those in the coming classes, right? So this is a quadrilateral, and in a quadrilateral, we have total 4 angles. They may be equal, they may not be equal. That is not our point, right? But these are the 4 angles that can be formed inside the quadrilateral. Okay. Make any 4 points A, B, C and D, join them to make a quadrilateral. Okay. Okay, so let's try to make a quadrilateral first of all, and then let's try to answer all this. Okay. Plot any points, mark any 4 points. So I plot A here, then B here, somewhere C here and somewhere D here. So let me join that. A, B, C, D and A. So this is how our quadrilateral is. Okay, A, B, C, D, quadrilateral A, B, C, D. Now the point is, the opposite side of CD, where is CD? CD is here. So opposite to CD, we have the side AB. AB or BA, both are same. When you're telling the side AB, A to B, or side BA, B to A, both are same. Okay. Next, the angle opposite to A. So the A is here. Angle B is just next to that, which is adjacent. Angle D is also, which is very next to A, which is again adjacent. But angle A and angle C, angle A and angle C, both are opposite to each other. Okay, the angle opposite to angle A is angle C. The angle opposite to angle A is angle C. Right? Next one. The adjacent sides of AD are. So for the side AD, AB is adjacent, and for side AD, even DC is also adjacent. Right? AD is here, side next to AD is AB or CD. You can write both the sides. The adjacent angles of angle C. For angle C, which two are adjacent? So this is one angle D and this one angle B. So angle D and angle B are adjacent to the angle C. Adjacent means next to next, side by side. Okay. So that is how you can try to write the angles, and you can represent the opposite sides and opposite angles. Moving forward, so let's try to discuss about a circle. Till now, we discussed about a polygon. These are closed figures. But polygon is a figure that is formed using line segments only. But using the curve, the closed figure, whatever we obtain is a circle. You can see here. This is a closed figure, right? But not with straight lines, it is with curves. So this is not a polygon. It is a circle. We say this as a circle. Circle is a simple closed curve. Why it is simple? Simple means it is not crossing its path. It's not crossing its path again, right? Circle is a simple closed curve in which every point on the circle is equidistant from the point called center. Let's try to understand once again. So there is a point in between, exactly in the center of the circle, which is itself is called center, which is exactly in the middle. And the distance from center to any point, center to any point. So all these are equidistant. What do you mean by equidistant? Equidistance means same length. This is x centimeters, this is also x centimeters, this is also x centimeters, or any units. Okay, so all these are of equal length. You can go, this is x, right? So this is also x. All these are of equal length, and this is called center of the circle. This is called center of circle, and this constant radius is called radius. This constant distance, that constant distance is called radius of the circle. Okay, so in a circle we have something called radius, we have something called center, we have something called circumference. So what are all these? Are all these same? Or center we just discussed, okay, in the circle, so that middle point is center. Radius, just now we discussed. Once again, let's try to discuss. And what is circumference? And after that we also have something called area and lot of other things that comes with circles. So let's try to start with the very basic thing of a circle, which is a radius. So what is this radius all about? You can carefully see here, radius is the distance between any point on the circle and the center. It is the distance between any point on the circle and the center of the circle. So this distance is r. We represent with r. Okay, small r. So this is again, this is small r, this is smaller. So all these are of a constant distance, which is called as radius of the circle. Which is called radius of the circle. Radius is the distance between any point on the circle and center. Radius is the distance between any point on the circle and center. Okay, so moving ahead, what is a diameter? Just now we discussed about radius. Now let's try to discuss about diameter. Diameter is a line passing through the center. Diameter is a line passing through the center and joining 2 points on the circle. It is passing the center and joining 2 points on the circle. See, this is passing the center and joining 2 points on the circle. So now you can tell me, is there any other diameter possible or only one? Why not? Passing through the center and joining 2 points, we have one more diameter. We have one more diameter. We have one more diameter. So we have many diameters. All these are diameters passing through the center and joining 2 points on the circle. Okay, so diameter is a line passing through center and joining 2 points on the circle and joining 2 points on the circle, right? And is there any relation between diameter and radius? Let me erase this. Let me tell you about radius here. Okay, see here. So if you observe, this is center, right? If this is center, this distance is radius, and even this distance is radius. The line from one point to the center, that is the radius. And I told you this complete thing is diameter. Let's try to write it as a d. So what is the relation between diameter and the radius? Exactly, correct. So diameter is equal to 2 times of radius. Diameter is equal to 2 times of radius. Diameter is twice the radius. Twice means 2 times. Twice means 2 times. Right. So we discussed what is a circle, what is center of the circle, what is a radius, and the double of that radius is called as a diameter. Right. Moving ahead, and let's try to discuss about a circumference. Before learning what is circumference, let me tell you what is a perimeter of a triangle or of a circle. Okay, perimeter, let's try to discuss about a triangle or quadrilateral. What is perimeter? Perimeter is a sum of all the sides, sum of lengths of all the sides. Okay, if I take a triangle where this is 3, this is 4, this is 5, so the perimeter is sum of all the sides. 3 plus 4 is 7, 7 plus 5 is 12. Right? So 12 is the perimeter. Now, if you're discussing about circumference, as we discussed perimeter for a polygon, the same thing is circumference of a circle. Okay. Circumference is the length of the curved edge. So it's the length of the curved edge. Circumference is the length of the curved edge, right? So this is a curve. So this complete thing, for example, if you take a thread, okay, keep it here and place it entirely on the circle. Place it entirely on the circle, exactly like this, and then try to take the thread and measure what is the length. What is the complete length? That means the curved edge. What is the edge of this figure? Which is nothing called It is a circumference. This complete length starting from this point to again the last point, that is called a circumference of a circle. Okay. So moving ahead, we have something called a chord of a circle. In a circle, we discussed what is center, what is radius, what is diameter, and now we discussed what is circumference, and now we are going to discuss about a chord of a circle. So is there any relation between chord, radius and diameter? First of all, let's try to understand what is chord, and then we'll move forward for the next two. Okay. A line segment joining 2 points on the circle. A line segment joining 2 points on the circle. Okay. So see here, this is one point A and this is the other point B. So if a line segment is joining these 2 points A and B, then we can say it is a chord. So now I'll ask a question, is there only one chord for a circle or many? We have infinite chords. You take any one point and join another point. Take any point and join another point. Take any point and join another point. Right? So all these are chords. All these are chords. So how many chords are possible? Infinite. Infinite chords are possible for a circle. Right? Diameter is the largest chord of a circle. So a chord which is moving from the center and joining the other vertex, edge, other end of the circle, right? So this is called diameter, and so the longest or the largest chord is nothing but it is the diameter. Diameter is the largest chord of a circle. Right. So let's move ahead. Let's try to understand what is an arc. So we discussed a circle, right? And we said that it is a curve. If you take a small part of that curve, that is called arc. Arc is a part of a circle. Part means it's a small part. Part of a circle. You can see here. In the entire blue circle, if you consider this curve, right? So that is called arc of a circle. Okay. Arc is a curve. You can see this small point, arc is a curve. Radius is not a curve. Diameter is not a curve. Chord is not a curve. But arc is a curve. All those are line segments. Right? But arc is a curve. Okay. So moving forward. So now let's try to discuss what is a segment. Region enclosed by an arc and a chord is called segment of a circle. Enclosed means that we're covered by an arc and a chord. Arc, okay, so this is an arc from here to here. Let us say this is an arc, and this is a chord. Arc and chord. So this complete shaded region, whatever it is called a segment. It is called a segment, right? Chord of a circle divides into 2 segments. So this is a chord which divides in 2 parts. One, the larger part, the other smaller part. Okay. So we can say that the larger part has major segment and the smaller part has minor segment. The larger part is called major segment and the smaller part is called minor segment, right? So this is how a circle, arc, chord, radius, everything are interconnected. Is it radius? No, radius always passes to center. So somewhere here to here, this is the radius. Okay, if you extend that becomes diameter, and diameter itself is the largest chord. And that chord and the segment with arc, the portion with the arc, that is called segment. And the larger one is called major segment, the smaller one is called minor segment. Okay, so what else we are having? Half segment is a segment formed by the diameter. So do you know what is diameter? Diameter is exactly passing the center and touching 2 other points. Correct? So this is exactly half. So whatever the reason 1 and the reason 2 are there, we can say 1 and 2 are equal. 1 is equal to 2. 1 is equal to such type of segments. A half segment, we say. Half segment is a segment formed by the diameter. It is a segment formed by diameter. Okay. Moving ahead, we have what is a sector. Please don't try to confuse with all this. Try to understand. Try to understand what is a radius, what is diameter, what is a chord, what is the longest chord, that is the diameter, what is a segment, what is an arc, and now what is a sector. There are many things that we need to understand in circles. Okay, so now let's try to discuss about the sector. Region enclosed by an arc and two radii. Arc and two radii is called sector. Arc and two radii. So you can see here. Region enclosed by arc and two radii. This is one radii and this is the other radii, right? One radii and the other radii. Now you can also ask me, so why not this is considered to be sector, why only this? No, both are sectors. The definition says that it is formed by an arc and its radius. You can take this arc or this arc. So again, like segment, major and minor segment, now we have major and minor sectors. We have major sector, that is the largest one, and the minor sector, that is the smallest one, right? So we can locate only one center in a circle. Is it yes or no? Is it true or false? Can you tell me? We can locate only one center. Yes, for a circle, we always have exactly one center point, one middle point, midpoint. Okay, so which is called the center of the circle. We can locate only one. Yes, we have only one center of a circle, right? What is the next one? Diameter is twice the radius. Yes, we have discussed that, right? So diameter is twice the radius. Radius, and this complete thing is diameter. So diameter is twice the radius. Diameter is twice the radius. We can say yes, it is correct. Diameter is twice the radius. Next one. An arc is a part of a circle. An arc is a part of a circle, correct? Okay, let's try to discuss what is an arc. For example, this circle. So a small part of the circle, I'll draw with another ink. Okay, a small part of the circle, this is an arc. So can you tell me, is it a part of the circle? Yes, the definition itself says that. Arc is a part of a circle, so we can say that yes, it is a part of a circle, right? So I hope you are understanding all this very well, right? And what else we are having? All chords are equal in length. All chords are equal in length. So let's try to draw a chord. This is one chord and this is other chord. So are these two equal? No. You yourself can see that this is wrong. This is small, this is big. You have more smaller chords, right? We have more smaller chords wherever it is possible. So not all chords are the same. So we say that no, all chords are equal in length is wrong, right? All radii are not equal in length. All radii. For a circle, from the center to any point, this is the radius, and as said, the definition of circle itself says that this distance, the radius, should be equidistant. Equidistant means all these values are equal to radius. All radii are not equal in length, which is false. It is a true. All radii are equal. All radii are equal, right? So I hope you understood all these topics. We have discussed what is a circle, what is a radius, what is circumference, arc, segment, sector. All these are the most important topics or the things which are going to cover with respect to circle. In the coming lecture, we are going to discuss more applications based on all this, right? So thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we'll be going into the practice on what? On learning how to measure, right? In this chapter we learned about length, area as well as volume. So my name is Sheshan Reddy. I'm a graduate from IIT Dhanbad. Let's quickly go into the questions. Okay. So first question is this, a very simple question. That is 1 kilometer is equal to dash millimeters. The conversion is between kilometers and millimeters. We have a few options. 100, 10,000, 10 lakh, 10 crore. do not forget, do not focus much on lakh and crore. Focus on the zeros. Focus on the zeros and select the correct answer. So I'll give you 1 minute of time. I'll give you 1 minute of time and please solve it. Take 1 minute of time and please solve it. But conversions is very important. You have to convert kilometers into millimeters. Kilometers into millimeters. "30 seconds more, everyone." "20 seconds more." You have to focus on the number of zeros. Be careful with that. The conversion is between kilometers and millimeters. Okay. 5 seconds more. 3, 2, 1, and the time is up. So what is the correct answer? The correct answer in this particular case, just a minute. Just a minute. The correct answer is option C. That's 10 lakhs. The number of zeros would be 6. But how? I'll explain. So here we are converting kilometers into millimeters. So first, what do we know about kilometers? We know that 1 kilometer is 1000 meters. 1 kilometer is 1000 meters. And what else do we know? We know that 1 meter is 10 centimeter and 1 centimeter is 10 millimeter. We know these three. And our target is to get the relation between kilometer and millimeter. So what I'll do is I'll first convert meter into centimeter, then centimeter into millimeter. Very simple process. We'll start with kilometer. 1 kilometer is 1000 meters, but again, as usual, you can write it as 1000 into 1 meter because 1000 into 1 is equal to 1000. And what is 1 meter here? Look at this. 1 meter is, sorry, not 10, 1 meter is 100 centimeter. 1 meter is 100 centimeters. So in place of 1 meter, I will make use of 100 centimeter. So see here, 1000 into 100. In 1000 you have 3 zeros, in 100 we have 2 zeros. That means if I multiply them, I'll get 5 zeros. But the unit will be centimeters. So we got the relation between kilometer and centimeters. Relation between kilometer and centimeters. But our target is to get the relation between kilometer and millimeter. So next step, convert centimeters into millimeter. That is going to be 1 lakh into, what is centimeter? I'll just write it as 1 centimeter. 1 lakh into 1 is equal to 1 lakh. Then what is 1 centimeter? 1 centimeter is equal to 10 millimeter. I'll use that here. In place of 1 centimeter, I'm using 10 millimeter. Then if you look at the zeros, when you multiply the multiples of 10, you can only focus on the zeros. Here in 1 lakh, you have 5 zeros, and in 10, you have 1 zero. So 5 plus 1, 6. So a total of 6 zeros. That would be 10 lakh centimeter. 1 kilometer is 10 lakh centimeter. Simple enough? Good? Okay, so that is the reason why the answer is what? The answer is option C. Good? Okay. Next question. 1 centimeter is equal to dash meters. You have a few options. So can you please select the answer? 1 centimeter is equal to dash meters. I think for this 15 seconds are enough. So please solve it. Done. And the correct answer is what? The correct answer is option A. Now how? That also I'll explain. Look at this. What does 1 centimeter mean? Or when do you get 1 centimeter? 1 meter divided into 100 parts, 100 equal parts, then each part will be 1 centimeter. So if you take 1 meter, imagine 1 meter, you divide it equally into how many parts? 100 parts. Then each part, one part will be 1 centimeter. So for 1 centimeter, you divide meter or 1 meter into 100. So division, divided by 100. So 1 centimeter is equal to 1 by 100 meters. That is the reason why the answer is what? The answer is option A. Okay, everyone, you have to be very careful with this. 1 meter is 100 centimeter, we know that, but 1 centimeter is 1 meter divided by 100. Good? Okay. Next. Now here the question is this: a stack of 20 coins has a thickness of 5 centimeter. What is the thickness of a single coin? You have a few options. I'll give you 30 seconds of time for this. 30 seconds should be enough. 30 seconds of time. So please solve it. Start. 30 seconds of time. Everyone, please. Very quick. Simple and should be quick. "15 seconds more. 10 seconds more. 5, 4, 3, 2, 1. The time is up. And the correct answer is option C. But how or why? I'll explain. See, look at this. If we have 20 coins, okay, like in this way. The 20 coins are placed one above the other. I'm not going to draw all of them. Like this, how many coins do we have? 20 coins, and the complete thickness is 5 centimeter. You have 20 coins, one above the other, and the complete thickness is how much? 5 centimeter. So for 20 coins, the thickness is 5 centimeter. But if I need one coin, what will you do? How will you get one coin? You divide by 20. But you do division on both the sides, not one side. 20 coins, 5 centimeter. For one coin, 20 by 20 is 1, will be 5 by 20 centimeter. What is 5 by 20? 5 fours are 20, right? That will be equal to what? 1 by 4 centimeter. What is 1 by 4? You can do the calculation, right? 1, 4. 4 zeros are 0. You subtract them. 1 will remain. Then you add a 0. You take a point here, decimal. Then you add a 0. 4 2s are 8. Again you subtract. 10 minus 8, 2. Again you add a 0, right? 4 5s are 20. You subtract and you get 0. That means the answer that you get is 0.25. Many of you should know decimals by now, right? Division and the decimals. So the answer is what? The answer is 0.25 centimeter. 0.25 centimeter, or in fractions it is 1 by 4 centimeter. Good. So the answer is what? Option C, 0.25 centimeter. Simple. Next. Who among the 3 boys is noting the reading properly? The 3 boys, they are given the names A, B, C. The name of the boys is A, B and C. Which of them is taking the reading properly? Which one? A or B or C? And the correct answer is who is taking it properly? B is taking down the reading properly, because B is directly above the reading, directly above. So B is getting it correct, and A and C are not exactly correct. They'll get slightly wrong readings. There are chances, but B will get a correct reading. Simple? Good. Next. While measuring the length of a needle, the reading of the scale or the ruler at one end is 2 centimeter and at the other end is 17 centimeter. One end is 2, the other end 17. What is the length of the needle? What is the length of the needle? I'll again give you 30 seconds. 30 seconds should be more than enough. So please take 30 seconds of time and then solve it. Please solve it, everyone. "15 seconds more. 10 seconds. 5, 4, 3, 2, 1. The time is up. So the correct answer is option A, 15 centimeter. But how? Let me explain. See, it's like this. You have a straight line. I'll do it in the next page. Let's say this is a straight line and I'm using a scale. So at one end the reading is 2 centimeter and at the other end the reading is 17 centimeter. At one end it is 2 centimeter and at the other end it is 17 centimeter. What will you do? To get the length you subtract them, that's it. To get the length you subtract both the readings, so length will be equal to 17 minus 2. 17 minus 2 is equal to 15. So it will be equal to 15 centimeter. It will be equal to 15 centimeter. Good? Simple? Done. So the answer is what? Option A, 15 centimeter. That's it. Okay. Next. What is the SI unit of area? Options M, M square, CM, CM square. So what is that going to be? What is the SI unit of area? In fact, what is the symbol of the SI unit of area? A, B, C and D. What is the symbol of SI unit of area? Everyone. And the answer is option B, M square. M is for meter, meter square or square meter. Square meter is the SI unit of area. Option B. Simple, understand this. If it is meter, it is the SI unit of length. If it is meter to the power 2, it is the SI unit of area, square meter. If it is m to the power 3, cubic meter, it will be the SI unit of volume. If one power increases, that means length becomes area or area becomes volume. Good? Okay, good. Next. A rectangle. Look at the question here. A rectangle has a length of 10 centimeter and a breadth of 5 centimeter. Length is given, breadth is given. What is the area of the rectangle? A typical question on the area of a rectangle. I'll give you 30 seconds of time again. 30 seconds should be enough. Yes? So 30 seconds of time. So please solve it. Please solve it, everyone. Length is given, breadth is given. All that you have to do is find out the area. "15 seconds more. Three, 2, 1, and the time is up. And the correct answer would be option A. Why? Very simple. Here let's write down the given information first. The given information is what? Length is given as how much? Length is given as 10 centimeter. Breadth is given as how much? 5 centimeter. Length is 10 centimeter. Breadth is 5 centimeter. What about area? Area is equal to length into breadth. Length is 10 centimeter. Breadth is 5 centimeter. Just substitute, will get the answer. What is this? This is the area of a rectangle. The formula, you have to remember the formula. You know, rectangle will be something like this. Right? So you visualize. Length is given as 10 centimeter. Breadth is given as 5 centimeter. We have to calculate the area. We use the formula, substitute. What about this? 10 into 5 is how much? 50. So it will be 50 centimeter square. It will be 50 centimeter square. Simple. Okay, good. Next. 1 meter square is equal to dash centimeter square, and we have a few options. A, B, C and D. I'll give you 1 minute of time, so please solve it. 1 meter square is equal to dash centimeter square. Again, another unit conversion. Thirty seconds more. Fifteen seconds more, everyone. 1 meter square is equal to dash centimeter square. So 5, 4, 3, 2, 1. The time is up. Now let us solve it. Okay. And the answer, by the way, is option C. So how will we solve it? Let me do this. 1 meter square. What does here the power 2 mean? What does the power 2 mean? It means twice. Meter comes twice. That means it is equal to 1 meter into 1 meter. 1 into 1 is equal to 1. M into M. So M comes twice. M comes twice here and here. So it becomes M to the power 2. Right? It becomes M to the power 2. So then, but we know that 1 meter is equal to 100 centimeter. So in place of 1 meter, in both the places, I'll use 100 centimeter. So 1 meter here is 100 centimeter, 1 meter there is 100 centimeter. You have it twice. Simple. Then 100 into 100. 2 zeros here, 2 zeros here, there are total 4 zeros. When there is 4 zeros and centimeter into centimeter, that is going to be centimeter square. That is going to be centimeter square. That's it. You got the answer. How many zeros? 4 zeros. That's why I tell you, focus on the number of zeros in such questions. So here the correct answer is option C, because if you look at the number of zeros, there are in fact 4 zeros. 10,000. 10,000 centimeter square. Understood? Good. Very simple. 3 steps and we got the answer. Then, liter is the unit of length, area, volume, none of the above. Liter is the unit of what? Length, area, volume, none of the above. What do you think is the answer? Everyone? Very simple, straightforward question. And liter is the unit of volume, option C. Liter is unit of what? Of volume. Simple. 1 liter of water. You buy, right? You buy bottles, right? Water bottles from shops. Mineral water bottles. They'll be of 1 liter, 2 liters, 1.5 liters, 20 liters water can. Liter refers to volume. Okay? Good. Next question. Acre is the unit of, this is an interesting question. Acre is the unit of length, area, volume, or none of the above. Again, similar question. The only thing is the unit has changed. So acre is the unit of what? Unit of area, option B. Acre is a unit of area. I have this many acres of land. I have 10 acres of land, 40 acres of land. What does that mean? It means the area of land. Acre is the unit of area. Okay. Next. Find the area of the shape shown here. Find the area of the shape shown here. I'll give you 1 minute. Please solve it. It's an interesting question. We practiced it. 1 minute. So please solve it. I'll keep it here. You can see the timer. So please solve it, everyone. What will the area be? Area of the shape shown here. Area of the shape. 30 seconds more. "15 seconds more." You have to count what? You have to count the number of squares. So time is up. Let me solve it for you. Let me solve it. Right. So let's first count the number of full squares. The number of squares that are completely inside the shape. So look at this. This square is completely inside. I'll tick it. This completely inside. Yes. This one is completely inside. This one is completely inside. This one is completely inside. Completely inside. Completely inside. Any other square that is completely inside? No. Not that I can see of. No. So how many ticks? How many complete squares, everyone? Look at that. 1, 2, 3, 4, 5, 6, 7. You have how many full squares? You have 7 full squares. Then how many half squares? I'll use dot. 1, more than half. More than half. 2, this also more than half. 3, more than half. That's it. What about this? This I don't think it is more than half. It will be less than half itself. So I'll not go into that. So you have how many dots here? How many more than half squares? Everything else. This is not more than half, 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 not more than half. This is also not more than half, not more than half, not more than half, not more than half. Even this is not more than half. So sometimes you have to be intuitive. Okay, obviously we can't, sir, how are you saying this as not more than half? I'm just using my intuition, my feeling. Because we can't exactly calculate, you have to be intuitive. So according to my feeling, according to my judgment, I'll say that these two are not more than half, they are less than half. So how many more than half squares do we have? That is the dots. How many squares did we select? Did we point them as dot? 1, 2, 3. 3. So what is the total count now? The total count is 7 plus 3, 10. The total count is how much? 10. So what about area? Area will be how much? See, each square, single square will be of how much area? Single square will be of area 1 centimeter square. The total count that we got is 10. So the total area will be equal to 10 centimeter square. 10 into 1 centimeter square. 10 squares, each square 1 centimeter square, total area 10 centimeter square. Simple? Yes? Good. Now another similar question for us. Another shape, in fact. Find the area of the shape shown here. Yes? Okay. So please try doing this, but I'll give you again 1 minute of time. I'll give you 1 minute of time, so please try solving it. It will be slightly lengthy, you have to be careful. You have to carefully count the number of squares, the full squares and the more than half squares. Those are the two that are important for us. "30 seconds more." The same method, but a different question, different shape. 5 seconds more. 3, 2, 1. The time is up. So let's solve it. So we'll first obviously go with what? We'll go with the full squares. We'll go with what? We'll go with the full squares. The ticks. I'll take this is a full square, full square, full square, full square, full square, full square, full square. Full, 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 full. Full, 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 full. Full square, full square, full square, full square. Full square, full square, full square. Did I miss anything? No. Right, now you have to count to them. Again, counting is also crucial. You should not miss anyone. Any square. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. How many? 26 in total. 26 full squares. 26 full squares. Then we'll go into more than half squares. This square is more than half. This is more than half. This is more than half. This is also more than half. As I told you, it depends on your judgment. This is also more than half. This is also more than half. This is not more than half. More than half. Not more than half. Not more than half. More than half. Not more than half. Not more than half. More than half. Not more than half. Not more than half. Yes, so we covered all the squares, all the parts. So full squares we got them as 26, more than half squares. Now let us count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me again count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are how many full squares? 9 full squares. So 9 more than half squares, 9 more than half squares, 26 full squares. So if we go for the total count, the total count will be 26 plus 9. 9 plus 6 is 15. So how much will it be? It will be 35. So if you go with the area, as I told you, the total count will refer to the total number of squares. We have 35 squares. Each square is 1 centimeter square area. The area of each square is 1 centimeter square. Total 35 squares. That means the total area is 35 into 1, which would be 35 centimeter square. The area would be 35 centimeter square. That's it. Done. Okay. Very simple, right? Ultimately, the method is simple. You have to carefully count the number of squares. Okay. So let's continue. Next question. 1 milliliter is equal to dash liters. You have few options. 1, 1 by 10, 1 by 100 and 1 by 1000. 1 milliliter is equal to dash liters. What do you think? The answer, everyone. 1 milliliter is equal to dash liters. The correct answer will be? The correct answer will be option D. Why? Because milli is 1 by 1000. That's it. See, kilo is equal to 1000. Yes or no? We say kilometer is equal to 1000 meters. Similarly, milli will refer to 1 by 1000. So 1 millimeter will be 1 by 1000 meters. 1 milligram will be 1 by 1000 grams. 1 milliliter will be 1 by 1000 liters. Milli. Okay. Kilo is 1000, milli is 1 by 1000. That's it. Understood? Good. Next question. When a stone is lowered into a measuring cylinder, the volume is 9 ml. The volume of the stone is 5 ml. Find the initial volume of water in the measuring cylinder. I'll give you 30 seconds of time because that's a question we have already solved. Right, so 30 seconds of time, please solve it. Find the initial volume of the water. What is that going to be? Ten seconds more. 5, 4, 3, 2, 1. The time is up. So here, what is the correct answer? The correct answer would be 4. Option B, 4 ml. How? Let us understand the question first. Here you have a measuring cylinder. Measuring cylinder initially has only water. Measuring cylinder initially has only water. And we don't know what that is. We have to calculate that. Let's say the level is, or the volume is V1. In the second case, we take the same measuring cylinder, but inside the cylinder there is a stone. There is what? There is a stone of random shape inside it. And in this case, it is given as 9 ml, which is equal to V2. So second case is what? V2. The volume in the second case is the volume of water in the first case. The water in the first case plus the volume of stone. So here V2 is given as 9. V1 we have to find out. Volume of stone, I think it is given as 5. Good. So if you need V1, you subtract 9 from 5 from 9. 9 minus 5, you get it as 4 ml. And hence the correct answer is B. So that very simple, straightforward question. Got it? That's it. Another question. A box is filled completely with 20 identical cubes of side 1 centimeter. What is the volume of the cube? You have a few options, so please solve it, everyone. Please solve it. A box is filled completely with 20 identical cubes of side 1 centimeter. What is the volume of cube? Please do it. Very quick. 20 seconds should be enough. I'm not giving you a timer in this case, so please solve it. What is the volume of the cube? So imagine there is a box in front of you. In that box, there are 20 small cubes. So what will the total volume be? Volume of the cube? No, volume, it would be, we need volume of what? Volume of the box. Not of the cube, but of the box. What is the volume of the box? Yeah, everyone. The correct answer will be option D. But how? Let me explain. See, each cube, or else I'll say volume of each cube. What is the volume of cube formula? It is A cube. But A is given as 1 centimeter. The side length is given as 1 centimeter. Cubes of side 1 centimeter. So side length is given as 1 centimeter. 1 centimeter cube, that means cube 3 times. 1 centimeter into 1 centimeter into 1 centimeter. 1 into 1 into 1. 1 centimeter into centimeter 3 times. So the power is 3. We got volume of each cube, volume of 1 cube. So 1 cube, it is 1 centimeter cube. But how many cubes are we using? 20 cubes. So 20 in the sense you are multiplying with 20. It's multiplied with 20. So here also you have to multiply with 20. Again same 20 into 1 is 20. The 20 cubes will occupy a full volume of 20 centimeter cube. And a box can carry 20 cubes. That means the volume of the box will be 20 centimeter cube. And hence the option is D. Hence the option is D. Good? Okay. So that's it, everyone. We have gone into a few questions based on length, the units as well as area and volume. So keep practicing. Okay. So thank you. Thanks a lot.